Submarines have two major advantages over surface ships. They are more difficult to detect and sink. Submarines pose a threat to an enemy, and thus influence enemy behavior, because they don't know where they are. To put it another way, even if those submarines are not in the area, or within striking range, their mere presence is a factor in opposing strategists' calculations, even if they are inactive, or appear to be immobilized. This is known as fleet in being, and it is the most effective form of naval warfare. In naval warfare, a fleet in being is a naval force that extends a controlling influence without ever leaving port. Simply existing and posing a threat, you have an effect on the enemy. India needs to fast-track the submarine project. In 1997, the Ministry of Defense approved a plan to acquire 24 submarines under Project 75. The older Project 75 was brought under the new plan, with the two production lines to be built under P-75 and P-75I, using transfer of technology from different foreign manufacturers. In 2017, the Indian Navy issued another RFI to naval group Rosaboronexport, ThyssenKrupp Marine Systems, TKMS, Saab Kockums, Navantia, and Mitsubishi Heavy Industries. While Mitsubishi failed to respond within the deadline, Swedish defense major Saab has withdrawn from the project, saying there has to be a rethinking on the policy. Germany's ThyssenKrupp Marine Systems has also withdrawn from the project, saying that it may not proceed with the negotiations, as it finds some of the tender requirements too restrictive. And now, the French company, Naval Group said, it is unable to participate in India's P-75I project, due to conditions mentioned in the request for proposal related to air-independent propulsion (AIP) system. This leaves India with only 3 original equipment manufacturers as finalists in P-75I. Daewoo Shipping and Marine Engineering (DSME) of South Korea, Rubin Design Bureau of Russia, and Navantia of Spain. China and India are increasingly competing in the Indo-Pacific, which is becoming a geostrategic focal point for both countries. China has sought to gain economic and strategic advantage by gaining access to strategic ports, while India's role in the region is increasingly seen as a defender of the international order established by the US in the region, particularly in terms of maintaining open sea lanes and freedom of navigation. As Chinese submarines are being spotted more frequently in the Indian Ocean region. For 2 reasons, India requires more submarines. First and foremost, India requires it for its maritime security. Second, in the coming years, China will deploy a large number of ships and submarines in the Indian Ocean. China is providing 8 submarines and 4 destroyers to Pakistan, which China can use as a proxy. India needs to deal with that as soon as possible and move on to P-75I. According to a Pentagon report from 2020, China currently has 4 SSBNs and is preparing to add 2 more hulls. It has equipped with 6 SSNs and 50 diesel-powered attack submarines. The Chinese Navy will likely maintain between 65 and 70 submarines through the 2020s, replacing older units on a near one-to-one basis with more capable units, according to the report. In the last 15 years, China has built 12 nuclear submarines. According to the report, it is expected to have up to 8 SSBNs by 2030. India has its own SSBNs, the INS Arihant and INS Aragat. Unlike other submarines, the SSBNs are strategic programs, overseen by the Strategic Forces Command and fall under India's Tri-Services Command, responsible for India's nuclear weapons. That's not a battle machine. Because it is a deterrent, it should not be counted as a submarine war fighting capability. What India really needs is an attack submarine or a hunter-killer submarine. Attack submarines can be nuclear-powered or diesel-electric, with diesel-electric submarines having air-independent propulsion systems. To match China's navy, which has over 350 warships, including 50 conventional and 10 nuclear submarines, India will need significant capability enhancements. By 2030, the Chinese Navy is expected to be a formidable force of 450 ships and 110 submarines. To compete with its rising adversary, in the future, India will need to significantly increase its naval assets. How are submarines detected? Each type of submarine has a unique sound profile that makes up the acoustic signature of the vessel. Passive and active acoustics are two methods for detecting and locating submarines. The goal of passive acoustics is to detect submarine sounds, such as propeller, engine, and pump noise. The Navy can use active acoustics to find submarines, in the same way that people use it to find fish. The sonars can determine the direction of the echoes that return from objects hit by the sound, by transmitting a sound pulse and receiving the echo on an array. They can also calculate the distance to the object causing the echo and the time it takes for echoes to return. These sounds can be identified by experienced sonar operators, dropping sonar buoys from aircraft and then communicating any data back to the launch aircraft via radio signals. Just as a microphone collects sound in the air, a hydrophone detects acoustic signals under the water. Most hydrophones are based on a special property of certain ceramics that produces a small electrical current when subjected to changes in underwater pressure. During the high-profile naval exercise Malabar, the navies of India, the United States, and Japan engaged in a simulated battle to hunt down and destroy each other's submarines. A conventional submarine from India, Sindhudvaj, recorded the hydrophonic effects of the USS City of Corpus Christi, SSN 705, a nuclear-powered attack submarine, and positively identified it before locking onto it. Being an exercise, only the firing did not take place. A sonar transducer that is dropped into the water from a hovering anti-submarine warfare helicopter and recovered once the search is finished. A transducer is an electronic device that converts energy from one form to another. Dipping sonar systems are normally deployed from helicopters hovering over a specific point. To detect submarines from an aircraft, magnetic anomaly detection (MAD) was developed. Magnetometers are commonly used to search for submarines, because submarines are made mainly from ferromagnetic materials, so their presence in the Earth's magnetic field will distort the field about them. Radars, on the other hand, are only useful when the submarine is on the surface. Non-nuclear submarines must surface on a regular basis or use a snorkel device to recharge their batteries, basically a long tube that breaks the surface and provides a supply of fresh air to the submarine's diesel engines. This is the primary reason why India requires an air-independent propulsion (AIP) system. Air-independent propulsion, or air-independent power, is marine propulsion technology that allows a non-nuclear submarine to operate without access to atmospheric oxygen.